Hello everyone, Assalamualaikum warahmatullahi wabarakatuh. Today we'll talk about introduction or it's not an introduction of you already got the introduction of algebra, but now we will have the advance of the algebra and the topic is related to the relations and functions. So when we're talking about the algebra, when we're talking about the functional, we also talk about variables, right? In here, variables is the basic elements of algebra. Usually we call it as x, y, a, b, c, and so on. Or sometimes we just like giving them as the alpha, beta, and so on. Okay, so it may be given any numerical value in the equations. So when we're talking about the algebra, we have the variables. And then we also have the functional of notation. What is functional notation? Functional notation is a way of denoting the fact that the value taken on by one variable, the y, and also the other variable in the x. In this case, we have y and x. Let me change the color red. This one, y is equal to the functional notation of x. So when you're talking about y functional of notation of x, we're talking about independent and dependent variables. We have y and x. As you can you can remember the previous slide. Okay, we have y and we have x. Which one is the independent and which one is dependent? As you can see, the meaning of independent variable is the algebraic equation when the variable that is unaffected by any action of another variable which is assigned by any value. So independent variable, it means that this variable is totally independent. There is no other affecting other variable. Okay, so let me clear this one. And we can see the notation function here. Yeah, which one is the independent? Is it y or is it x? I know that some of you are answering with the x. Why is x? Because it's if it is 1, if it is 2, if it is 3, it is not affected by the y. In different cases, if the x is changing, so the y will be changing also. So the y is dependent variable, or we can abbreviate it as dv, right? And independent variable, we can abbreviate it as IP. Okay. Let me switch my battery on. Okay, we have independent and we have dependent. So you already know what is dependent and what is independent variable. Okay, so we're talking about, we already have the forms of functional relation. Y, notation of functional of x. Okay, if we're making some y plus a plus bx, we call it as linear function. Yeah, linear function. This is the example of linear function. But if we found that y is equal to minus x quadrat plus 15x, we call it non-linear function. We have several of non-linear function. One of them is quadratic. Okay, the one is the most known, yeah, for you since you are in junior high school and high school. minus x quadrat plus 15x. Okay, this is a non-linear function. Linear functions usually the curve will be like this one, right? Or this one, okay? But non-linear function, it could be curved like this one, or other like this one, yeah? Or in the other like this one, or can be like curved, halfly curved, something like that. So I know that all of you already recognize what is nonlinear function. So we have the example of linear functions. Y equal to 3 plus 2x. Okay, and the quadratic y is minus x quadrat plus 15x. Therefore, we are trying to make a table like the schedules of between x and y, between x and y. If v x is minus 3, the result of y is minus 3. If the x is minus 2, the y will be equal to minus 1, and so on. The most impressive one is 0. It will be equal to 3. It's also when we are making some schedule of the quadratic function, you also can put like this one. When the x is minus 3, so the y is minus 15.4. Is if the x is minus 2, so the y will be minus 34. Minus 1, the y will be minus 16. Based on this one, how to measure it? Yeah, you just put it the x as minus 3, right? So just put it minus 3 quadrat plus 15 times minus 3. How much is it? Minus 9 plus how much is it? Minus 45. So it's equal to minus 47. So you can put the x here, replaced by each of the schedule of the x, number of the x. So when we're talking about, we already talked about independent variable, we're talking about the independent variable. Now we're talking about graphing the function for one variable only. One variable is y equal to fx. Ma'am, what it will be if we have two variables? If we have two variables, we can make it like y equal to f x1 and x2. Or 3, we can make it y f x1, x2, and x3, yeah, and so on. But now we are focusing on one variable first. The graph we use to show the relationship between two variables. Unfortunately, I'm making some not good. Okay, to show the relationship, yeah, the relationship between two variables. If we have the y equal to fx, so this is the relationship between y and x. Okay. Usually the dependent variable, the y, is shown on the vertical axis, this one, and the independent variable shown in the horizontal axis. So this is y, this is x. If you still remember the demand curve, right? Supply and demand, yeah. What is the y? Here is the price, and this one is the quantity. So it should be like P F for Q, right? For quantity, the price, the functional variable of T for dependent variable of price. Okay. So this is an example of the linear function. So we can exercise now from previous one. we have this one. Probably you can see it in PDF, okay? If you see this one. Expand in the following and collect the like terms. If we have this kind of the equations, 2x, okay, this is number 1, 2x plus this one is have to be multiply first, 3x plus 3, okay, plus 4x plus 8. How much is it? 2 plus 3 is 5, plus 4 it's 9x, plus 3 plus 8, 11. Okay, so expand the following and collect like terms. We already got this one. And the second one, 8x minus this one, 2x minus 6 plus 3x plus 12. So how much is it? 8 minus 2 is 6 plus 3, 9x. Yeah. Minus 6 plus 12 is plus 6. See, we can have this one. So the algebra is quite, I think for you it will be very easy for doing the algebra. Okay. Okay, now we starting with the linear function. As you can see, you still don't remember y is equal to 3 plus 2x. Yeah, here. So how to make it? How to make the graph then? Y is where's my cursor? Oh, this one. Y is 3 plus 2x. How to make it then? You can make it like if this is y, this is 8, right? If y is 0, how much is x? If x is 0, how much is y? Now we can see if x is 0, y is 3, okay? If y, this one is 0, how much is it? What is it? So it will be 0. It means that mean minus 2x equal to 3. X is 3 bar minus 2 minus 1.5. Okay, so we already have y. If it is 0, the x will be minus 1/2. Okay, 1.5. So you can see that if it is minus, if y is minus, if y is minus, okay, now we can see the x, okay, this one is y, this one is x, okay. The y is 0, the x is, sorry, the y is 0, the x will be minus 1.5 here. If the x is 0, the y will be 3. So the graph will be like this one. Okay, you can make the graph will be like this one. You can check, double check. Yay, you are correct. This one is minus 1.5. Okay. So when we are graphing, trying to draw the graph of the linear function, make sure if y and x. If y is 0, how much is x? If x is 0, how much is the y? Okay. Now we're talking. We see that this line you can see here. Now we're talking about what is 3, what is minus 1.5. We call it as y-intercept. This is the y-intercept. 1.5 is x-intercept. Why we call it as y-intercept? Y-intercept. Intercept, we have the intercept came from the general form of the linear equations. The y-intercept will be appear if the value of y calculating when the x are 0. So how much is y when x is 0? So we call it as y-intercept. Okay. And how about this one? Let me make it like this one. Okay. And how about the x-intercept? If x-intercept will be appear as the same, right? If x-intercept is appear when the y is 0. So how much is the x? So this is the x-intercept. Okay, now we're talking about the slope. Intercept, but when you are talking about the intercept, it means that you are talking about the graph, yeah. Which point is the previous one is the 3 and 1.5 minus. This is the intercept, yeah. This is the one which is cut by the curve. Okay. So the second one we're talking about slope. What is the slope? The slope is any straight line in the becoming a ratio by the changing of y and changing of x. The slope we can measure like this one. The changing of y and changing of x. Yeah. Changing of y and changing of x. So what is the meaning of changing? So probably we can make some example here from the equation y equal to 3 plus 2x. We can call the slope is equal to 2. Why it's becoming equal to 2? Because you can see that when the x is increases from 0 to 1. If x 0, y is 3. If x equal to 1, y will be 5. Okay, so now when increases from 0 to 1, and this one is increases, how much the increasing between the y, yeah, this one is the x1, this is x1, x1, this one is 0, x0, and x0 and y0. We can measure like this one. 5 minus 3, yeah, divide 1 minus 0, because we have to find the differences between the y and the x. So we can have 2, yeah, this one. So how much um, how to measure the slope you already got from the changing of y and x. So now we can make some graph completely. This is the intercept, yeah, for y and intercept for x, and the slope is 2. Yeah, wait for a minute. I think I saw some of the hand. Okay. I saw my hand in my glasses, so it's so annoying. I'm sorry. Okay, we can see in here, we already have the y-intercept, and we also already have the x-intercept, and the second one, we already also measured the slope. Okay. So the slope is the same along straight line, okay, like this one. All the slope is the same, yeah. For the general form of the linear equation, the slope equals to b. The slope can be positive, negative, or even 0. In this case, we have positive 2. Okay. If the slope is 0, the straight line is horizontal with y-intercept. If slope is 0, it will be like this one. Okay, with the y-intercept. Oh, sorry, it should be y-intercept. This one. Okay, with the y-intercept. Slope and unit of measurement. The slope of a function, it depends on the units in which x and y measured. If the dependent variable is the equation of this one, yeah, we call it as an income and measure the $100. For example, 100, right, increases would result in 2 more units of y. If the same relationship was modeled but with x measured in a single dollar, the equation will be, if the same relationship but the model with the measured of a single dollar, so the equation will be like y is equal to 3 plus 0.02x, or the slope will be equal to 0.02. Yeah. So the changes in slope, when we are talking in economics, we always mostly interested in the changes of parameters between a and b from the linear equations. If you still remember the figure 1a plus 1a2, it was negative slope doubled with the intercept and held constantly. In general, a change in the slope of function, it will be cause the rotation of the function without changing the intercept. It will be like this one. For example, changes in the slope of a linear function. So it will be changing, but only changing the x. For example, if this happened in economics, if the price dy is decreased, but the x is decreased. Sorry, this one is x is decreased. Or if economics, if it is P or Q, it means that the price of goods is decreased. So if it is increasing like this one, it will be decreased. Sorry, it should be increased, yeah. So because your ability to pay is increased. Your ability to pay is becoming less. Yeah. Yes. Usually you can buy 10 unit of eggs, but suddenly you cannot afford to buy 10 because there's some increasing of the price, so the eggs will be decreasing to be 5. So it's becoming like changing, right? Changing like this one. But if we're talking about changing in intercept, we will talk about in figures this one. Yeah. If the intercept is changing, we found that intercept y and intercept x and y intercept is 5. Now changing, yeah, becoming 10 and 10. So it will be shifting, okay? It will be shifting, and the linear from y equal to minus x plus 5 becoming y equal to minus x plus 10, because it's shifting, right? Shifting into the upper. So this is the changes of intercept. Yeah, this is need to be remember. The intercept will be shifting into this side, but if you are changing into the slope, it will be like changing in, sorry, changing in this part. Okay, only changing in this one. So it will be slow, and if it is changed here, shifting a bit, like in this case, intercept is changing. Okay, that's it, our class for today. So I hope you understand about our keywords now. Yeah, linear, non-linear, yeah. And then we have intercept, yeah, and we have slope. If the changing on intercept, yeah, it means that it's shifting. If it is in slope, it means changing. Yeah, so you need to remember slope. We are talking about the changing of y to x. Intercept, we're talking about the x equal to 0 will be y-intercept. If y equal to 0, it will be x-intercept. So you need to remember between intercept and slope. Okay, that's all for class today. And please practice your math skill into the using the PDF. Yeah, I think we already uploaded into my class. Please upload it in there. Sorry, make practice, because practice make you better to have in mathematics. Okay, thank you so much. We'll meet you again probably next week. This week in Friday, I will meet Mas Fitra will share you about algebra factorization. Okay, thank you so much. Keep healthy, keep safe. Assalamualaikum warahmatullahi wabarakatuh.